My name's Mike Kostersitz, and for the last years I've been working with a team of engineers to create an application platform for modern .NET applications, Azure Kubernetes services on Azure Stack HCI. AKS HCI simplifies running Kubernetes clusters, all with AKS-consistency on premises. Integration with Azure Arc enables Azure services natively. This session is full of demos to help you get started with AKS HCI. AKS HCI is hybrid by design, the best platform for .NET applications on your terms and built with security from the ground up. Looking at the architecture, there are two high-level parts, the management infrastructure and the target cluster. Let's get started. In episode 1 of this 7-part mini-series on AKS HCI, Matt will walk us through a deployment of AKS HCI and a sample application, using Windows Admin Center and PowerShell. Matt, take it away.
So we'll first deploy the AKS on Azure Stack HCI management infrastructure using Windows Admin Center. So first we'll go into system checks, we'll provide some appropriate credentials, and then Windows Admin Center will check the system to ensure everything's set up correctly, and we'll apply those configuration changes if required. We'll then ensure that Windows Admin Center can connect to the environment correctly using CredSSP, and we'll move on to setting up our host. We'll define our storage location for our images and our virtual machines. We'll define our network settings, in this case DHCP, and apply an IP address range that will be used by our Kubernetes clusters. Then we'll configure the Azure registration, which will pull in my login credentials from Windows Admin Center. I'll define a subscription, create a new resource group that's going to hold our registration information in Azure, and a region in Azure that's going to contain that resource group. We'll review our settings that we've made, ensure everything's correct, and apply that configuration. And that's going to just take a few moments. Once that's complete, we can move on to the deployment of AKS on Azure Stack HCI's management infrastructure. And as you can see, in this case, it took around 12 minutes. And with that completed, we can see all the information about our AKS on Azure Stack HCI infrastructure, and we're ready to move on to deploying new Kubernetes clusters to run our workloads.
Thanks, Matt. Now that we have a management cluster, we can look at creating our target clusters and also bring up an application. Coming back to the architecture, when you deploy Kubernetes target clusters, AKS HCI automatically deploys a set of VMs to act as the control plane for that cluster, including at least one load balancer.
Now, before we deploy our first AKS HCI Kubernetes cluster, let's get the versions of Kubernetes that are available to us, and you'll see we've got a selection across both Linux and Windows Kubernetes versions, so that's great to start with. Then let's explore some of the parameters associated with this new AKS HCI cluster command. And you'll see we've got choices around setting the size and number of VMs that we're going to deploy, whether we want to integrate with Active Directory, the Kubernetes version, network plugins, and more. But let's lock in this new AKS HCI cluster command, specifying a name, one control plane node, one Linux node, and one Windows node, and we're going to use Calico networking in this case. And that's going to kick off deployment. And you'll see within just a few short minutes, we'll have our new Kubernetes cluster up and running. Once completed, we can then retrieve the credentials of this particular Kubernetes cluster. And you'll see that downloads the kubeconfig file that we can then use to communicate and work with that cluster going forward. And it stores it in this case, in the local file directory. With that deployed, we can now integrate this cluster with Azure Arc for governance, security, and management, and more. So it's a simple command, enable AKS HCI Arc connection, and that's going to go ahead and integrate this particular cluster with Azure Arc. And it takes just a few minutes, a number of pods are deployed down to the cluster, and once that's completed, if we go to the Azure portal and take a look here, there's the management cluster we deployed earlier. And if we click refresh, you'll see we now have our new Kubernetes cluster ready to run our workloads that's integrated with Azure Arc, where we can go on and enable things like GitOps, Azure Policy, and more.
Great work, Matt. On the next episode, we will see how to make use of the Azure Connected functionality. Previously, on introducing AKS HCI, Matt showed us how easy it is to deploy AKS HCI and run a simple application. Austin will now use the connection to Azure through Azure Arc and Azure Monitor to keep tabs on our application, detect and fix issues before they become a problem.
Hi everyone, I'm going to show you how you can use Azure Monitor to collect metrics and logs to deliver a comprehensive monitoring experience for your AKS and Azure Stack HCI clusters. In previous demos, you saw how you can connect your AKS HCI cluster to Arc. This Arc connected cluster already has Monitor enabled on it. Now let's imagine this scenario. You're a developer that has deployed an application across multiple AKS HCI clusters. You want to make sure that there aren't any application errors. To check that this is indeed the case, we navigate to the Monitored Clusters pane and check your list of connected AKS HCI clusters. In this blade, you can see the full view of your Kubernetes environments across different tenants, its subscriptions, and cluster types. We see we have our AKS HCI clusters, and we notice that the user pods has an issue with it. Clicking on it navigates us to the Insights blade. Here we see the full view of controllers for this cluster. Sorting by status, we see the purchasing app has an issue with it. Expanding the row gives us more information. Clicking in, we can now view in analytics and see the full details of why this is the case. Opening up a query in a log analytics workspace, which will run and generate all the container log and events associated with this container and help us with troubleshooting. With this, we're able to start from identifying an issue and drilling down to detect where the problem might come from. Next, let's talk about the dashboarding experience. Here in the cluster blade, you can see that we have various charts, each of them with a pin icon in the upper right-hand corner. Selecting this pin icon allows us to pin to our dashboard. Now that I've successfully pinned this, we can navigate to the dashboard and see the newly added visualization. This is a great way for creating a day-to-day monitoring dashboard where you can see all your resources across your subscriptions and environments. For example, we have application, infrastructure insights, as well as health and application maps. Finally, we move on to our last scenario, recommended alerts. Recommended alerts are alerts generated from the metrics collected from Azure Monitor, and they're a great way for detecting issues and events associated with your Kubernetes clusters. Here, turning on an alert is as simple as a click of a button. This container CPU percentage will now send an email to my selected action group whenever container CPU is greater than 95%. With a few quick and easy steps, you can leverage Azure Monitor to get a consolidated view of your applications, Kubernetes clusters, and the underlying infrastructure metrics. For more information on Azure Monitor, visit aka.ms/azcoinarc. Thank you.
Previously, on introducing AKS HCI, Austin showed us how to monitor an application and detect errors and fix them before they became issues. Right now, anyone in the organization can deploy any application to my cluster and expose it to vulnerabilities. In most cases, you might want to limit that access or control who can do what in the cluster. On this episode, Avilasha will show us how to secure the AKS HCI cluster and govern the application deployment.
Hey everyone, I'm going to show you a demo of how easy it is to use Azure Policy for Kubernetes with AKS on Azure Stack HCI. Let's imagine a scenario. You're a developer and you've deployed an application across multiple AKS on Azure Stack HCI clusters. You've recently found out that your organization mandates the use of images from trusted registries to reduce the Kubernetes cluster's exposure to vulnerabilities and security issues through malicious images. You want to ensure that you are in compliance, but you don't want to write time-consuming scripts or perform manual checks. Azure Policy has you covered here. Let's go to the portal and create a policy definition that will help you do this. In previous demos, you saw how you can connect your AKS HCI cluster to Arc. This Arc connected cluster already has policy enabled on it. Click on Policies and then click on Assign Policy. You can now choose your policy definition from the list of built-in Azure policies that are ready to use. This built-in policy identifies all the application instances where you are using container images from untrusted sources. To ensure that you're using images from trusted repositories like Microsoft Container Registry, type in the regex for it in the list of allowed images and then click on Create. This policy, applied at a subscription scope, will evaluate the AKS HCI clusters in your subscription and will flag the ones which have an application running with unapproved image. After some time, you can see that 2 of your AKS HCI clusters have unapproved images. You can also click into the clusters to get a more detailed view of the containers in question. This is how easy it is to use Azure Policy with AKS HCI to ensure that your applications in Kubernetes clusters are secure and compliant. In this demo, we used the built-in policy definition. Azure Policy has many such built-in policy definitions that you can choose from to securely manage your clusters and applications. For more information on built-in policies and how to set up Azure Policy for Kubernetes, visit aka.ms/AKS-policy-doc.
Wow, this is powerful functionality. Thanks, Abhilasha. On the next episode, a legacy.NET app will start its journey to Kubernetes. Previously, on introducing AKS HCI, you have seen the deployment of an AKS HCI infrastructure, workload cluster, and application, how to connect to Azure Arc and use Azure Monitor and Azure Policy to secure and look after your application. Vinicius, fire up Windows Admin Center and bring this legacy app into this decade.
So here I have an AKS HCI cluster that was deployed using Windows Admin Center. I also have a target cluster where my applications are going to reside. So let's take a look at how to deploy an application using the containers extension. I can target the Kubernetes service and see my cluster that can be either an AKS or AKS HCI cluster. By looking at my AKS HCI cluster, I can see that I already have 2 applications up and running. So let's see how we can deploy a new one. We can create a new workload definition and provide some information about my application, like for example, it is in AKS or AKS HCI, give the application a name, say what type of application is this one. On the configuration settings, I can go and say what kind of deployment this is, what my subscription and the container image I want to use from ACR, say how many replicas I want for my pods, the container port number, CPU limit and memory limit, as well as the minimal CPU and memory. This is a Windows application, so I can select that option and move to the next step. Here we are going to deploy a service, which is a load balancer, so we can give it a port as well. And as you can see, a YAML file was created for me for my application using Windows Admin Center. Now I can select the YAML file created by Windows Admin Center and deploy it to my AKS HCI cluster. I can either provide a configuration or use the saved settings from a previous cluster that was used. As you can see, the configuration was applied successfully. So I can go look at the cluster now using the saved settings. And as you can see, we have now the ViniBeer application up and running. This information is pretty much the same as you would get from kubectl. In fact, if I go look at that configuration right now, I can see that I have a deployment, just like I saw on Windows Admin Center. I also have a service up and running for the ViniBeer application. So let's take a look at the application up and running on the browser. Here I have my application up and running, deployed using Windows Admin Center to AKS HCI. The application itself gives me how much sugar I should be adding to my recipe when brewing beer at home. And with that,
really cool, Vinicius, to see how easy it can be to bring a legacy application to this decade. On the next episode, the Group Managed Service Accounts Improvement Show. Previously, on introducing AKS HCI, we have seen that you can very easily migrate a .NET application to modern containers. One aspect of legacy.NET applications on Windows is often Active Directory authentication. In the container world, that is achieved by using group managed service accounts, which required, until now, the overhead of domain joining the container hosts. Jing will introduce us to GMSA non-domain join, which removes this dependency.
Active Directory authentication is supported in Windows Container through a special kind of service account called Group Managed Service Account, GMSA. In this demo, I will show you how easy AKS HCI can deploy Windows application with GMSA using non-domain joined host solution. Here we have a AKS HCI target cluster with at least one Windows worker node. First, let's enable GMSA webhook using a PowerShell commandlet. Then, create a secret which stores AD user credentials to retrieve GMSA password. Next, we are ready to create a GMSA credential spec to the cluster. Now we are ready to deploy the application. This application is a typical ASP.NET application with SQL backend server. Notice the name credential spec resource is referenced under secret context with the secret we created earlier. Let's deploy the application. We can see the application and service are running. This is the application homepage. To demonstrate the GMSA is working, You can add a list of books. All the books information are retrieved from SQL backend service. You can add a book. To validate even further, you can log into SQL backend and see GMSA login record reference in the credentials path. Thanks for watching.
Awesome. Thank you, Jing, for making our customer lives easier by removing an administrative step for using GMSA. On the next episode, AKS HCI will get vision and provide new insights to manufacturing applications. Previously, on introducing AKS HCI, Jing has introduced GMSA non-domain join, removing one of the barriers of using GMSA with Windows containers. Now that we have a working Kubernetes infrastructure, we can use it to run exciting new applications and services. Payment will introduce one of these services, Vision on Edge.
AKS HCI is a great platform for running both legacy and new cloud-native hybrid by design applications. Vision on Edge is an open source application by our team designed to simplify the development and deployments of camera-based AI analytics at the edge. This hybrid application combines the capabilities and versatility of Azure Cloud with AKS HCI's secure and scalable edge capabilities to unlock and showcase a new way of building applications optimized to use both the cloud and the edge. The solution was initially developed to run on Azure IoT Edge devices, but I'm happy to announce that now you can deploy the same solution on AKS HCI and take advantage of all of its goodness. Here you can see the overall architecture of the solution. The only two requirements for running the solution are Azure IoT Hub and Custom Vision deployed on Azure Cloud. We have detailed documentation that goes through the deployment process, but in essence, we are going to use our Helm chart to deploy the solution onto our AKS HCI cluster. Here I am in my management machine that has access to my cluster. To deploy the solution, you need to create a YAML file with the following structure and input your required authentication values. I can now install the solution on my cluster with only one command. After submission, you will get instructions that help you check the status of your deployment. Once the deployment is complete, you can view the IP and port of your deployment by running the commands given in post-deployment instructions. Let's check out our application. Here we have the main page of the solution. You can use this scenario library to deploy one of our pre-built business-driven scenarios. Let's deploy our counting object scenario. In this scenario, we are showcasing how you can use your plant's cameras to count the number of objects going through a production line. Let's try another scenario. Another scenario that is great for a manufacturing plant is defect detection. In our defect detection scenario, you can use your plant's camera to detect and count number of defects that are going through your production line. With the power of AKS HCI, you can build and deploy hybrid solutions just like Vision on Edge and address your intensive edge computational needs. The great thing is that, as we saw earlier in previous demos, all your edge workloads are manageable using single pane of glass on Azure. If you would like to deploy Vision on Edge onto your AKS HCI cluster and also learn more about its capabilities, please visit the link on the screen. We have detailed and easy to follow instructions that can help kickstart your intelligent edge application development on AKS HCI. Back to you, Mike.
Thanks, Payman. This is an impressive hybrid capability and shows the power of the combined platform of Azure and AKS HCI. Stay tuned for the final episode of this series, where we will take a look at the security work that has gone into AKS HCI. Previously, on introducing AKS HCI, Payman has walked us through the example of the Vision on Edge application and shown how to harness the power of hybrid containerized applications with AKS HCI. In the last regular episode, Sumit will walk us through some of the secure by design features which make AKS HCI a great platform for edge workloads. Sumit?
Okay, the first thing you're going to do is you're going to create a target cluster with AD auth enabled. We're typing the new AKS HCI cluster and providing the parameters. As you can see, it's putting the configuration, creating the cluster. We're assuming that the management cluster is already set up. Next, we're going to configure the authentication with a key tab. We have already generated a key tab, which is not shown in the video, and we're installing AKS AD auth with the key tab that has been pre-generated. Now we're going to create a regular kube config. This is the kube config that uses certificates. Now you're going to look at the kube config. This is a certificate-based kube config. Now we are going to create the AD kube config. This is the kube config that has no secrets, and that is the benefit of AD auth. I'm waiting to see the kube config. After it has been generated. As you can see, there are no secrets. This can be freely distributed. Now you're going to try to access the cluster from an unauthorized AD account. Now we are going to try to access the cluster from an unauthorized AD account. As you can see, it says cannot list resources in API group. Now that is the benefit of AD SSL. We're going to test Azure Defender integration with AKS HCI. The first thing is that we assume that the cluster is set up and the Defender agents are deployed. The required subscriptions are added. First thing we do is create the Azure Gate extension for Defender. Then we test that the Defender extensions are deployed as pods. As you can see, we can see the Defender pods deployed. Next, we're going to query a reserved namespace, which is considered a potential security warning. We go to the Defender portal and it will show us in security alerts. We can see the alert. As you can see, Azure Security Center H1 Cluster 1, that's the cluster we deployed. And then we're going to go and look at the same alert in the command line. We put in the required command parameters, and as you can see that in the command line they show up as well. So Defender is able to detect alerts.
Thank you, Sumit, for showing the in-depth security features in AKS HCI. We're almost at the end of Season 1, but we have a bonus episode for you, a real treat, so stay tuned. Previously, on introducing AKS HCI, we have seen how to deploy, monitor, govern, use and secure your applications in theory. On this special episode of introducing AKS HCI, we have one of our early adopter program customers, SKF, show how they use AKS HCI.
Hi, I'm Sven Follebeer, Head of Digital Manufacturing at SKF Group. SKF is the world's largest bearing manufacturer. SKF supplies to more than 40 industries globally, products and services both directly and indirectly through a network of over 17,000 distributors. Let's look at the key challenges in SKF digital manufacturing. To serve our customer in today's rapidly changing market requires the cleanest, smartest, safest, most efficient and flexible factories in the world. These factories need their IT/OT platforms, execute workloads locally, have IT services deployed with speed, have systems operate with reliability and security, and as we need 100 of these platforms, have them to a low cost. We looked how we could meet all these requirements while reducing implementation and operating cost. We are very Microsoft centric at manufacturing, so it felt natural to decide to go with Azure Hybrid Solutions as a standardized IT platform across all factories. We plan on standardizing on Kubernetes as the primary hosting platform for modern workload. The fact that Microsoft has also chosen Kubernetes strategy running their other products allows us to deploy, for example, Azure Arc enabled data services virtually on any of our new or existing environments. Let's look at the architecture. As mentioned, we need to run our workloads locally due to requirements set by critical production systems, but we would like to manage the environment with the same convenience as we get from cloud platforms. We have our Azure Stack hardware standardized to virtually a single catalog node, and we can offer t-shirt size options to our factories by controlling the number of nodes. We have the hardware pre-connected with Azure and pre-configured with Azure Hybrid Services. We get a lot of deployment speed from this kind of a delivery model. We need furthermore a cost-efficient way of managing all the workloads and their lifecycle. We do this based on Azure Kubernetes services on Azure Cloud and Azure Kubernetes services on Azure Stack HCI. And also Azure Arc enabled Kubernetes on legacy Hyper-V platforms. Together with automation tools, we can significantly reduce resource requirements to delivering on the workloads, as well as increasing at the same time productivity with the developers. We are very excited about this. This gives us a tremendous jumpstart in the digitalization. Thank you for listening.
Wow, what an exciting finale. Over the last 20 odd minutes, you went through a whirlwind view of core capabilities in AKS HCI: deployment, monitoring, policy and governance, application modernization, hybrid edge applications with division on edge app, security. This is only the beginning. Make sure to watch the full episodes in our skilling video repository and check out all the other resources listed here. I want to thank the team and everyone involved in making AKS HCI possible and who poured their hearts and souls into the product.